Hi everyone, welcome to tonight's webinar. For those of you who don't know me, my name's Vanessa and I'm the UK Sales and Operations Manager for Erchonia. And we have a really interesting webinar coming up for you this evening. So tonight we are joined by two industry professionals, Dr. Nichola and Dr. Erik Reis. And we will be talking through how you can really integrate low-level laser along with the right one, nutrition, and two, the right type of supplementation to get the best possible outcomes for your patient. There's quite a big shift in the industry happening at the moment, with a lot more patients requesting and demanding more longevity-based treatments, which is where these two kind of big technological advancements can come into place. So we are going to spend about 40 minutes educating you, and then we'll have about a 15-20 minute Q&A at the end. So if anyone has any questions, please put them in the question box and we will address all questions at the end. So I'm going to pass you over to our two fantastic presenters for this evening, and I hope you all enjoy the webinar, and we will get back to you with any questions very soon.
Thanks, Vanessa. Appreciate that. Nichola, I'm going to let you go ahead and take it away for us.
Fantastic. Well, thank you so much, everyone, for joining us today. Erik is going to be in charge of moving the slides. So if you see me doing some funny eye movements or winks, that's to move the slides on. But my name is, as Vanessa said, is Dr. Nichola Conlon. I am a scientist. I am an expert in cellular health. Or more specifically cellular aging. So what it is that goes on inside of our cells to cause all of the signs and symptoms that we experience as the aging process on the surface. And I am the lead scientist and founder of Nichola Laboratories. And at Nichola, our mission is basically to translate all the latest science in the field of aging and longevity and basically turn this into consumer products so people can have access to this science and implement it into their routines and into their clinics. So I think it's pretty safe to say that when we think about, treating aging at the moment, we are very focused at looking at what's going on the surface. So all the signs and symptoms of aging that are appearing on the surface level and looking at interventions and ways that can work at this level. But what we know actually is that although we're experiencing things on the surface, aging actually starts at the cellular level. And this means that if we really want to do something about aging, we actually need to start targeting the cellular level. So this diagram here is just showing that we are really focused on treating aging at the surface, but when it comes to skin, for example, if we want to really move the needle on the aging process, we actually need to be looking at the cellular level. So in the case of the skin, this would be looking at the skin fibroblasts. So now that we know that everything to do with aging starts at the cellular level, this has really led to a big push from scientists such as myself to look at a concept called biological age. So your biological age is the rate at which your cells are actually aging on the inside. And what many people don't realize is you actually have two ages, okay? So you actually have your chronological age, which everyone will be familiar with. That is just the number of years since you were born, the number of candles on your birthday cake. There's nothing you can do about that one. But we also have a biological age, and the biological age is much more important because actually this is the rate at which our cells are aging. So it's considered a much more accurate reflection of the aging process, and most importantly, there is something you can do about your biological age. So just when explaining biological age, you can see here some examples, because a really interesting thing is that quite often your chronological age and your biological age don't often match up. So for example, on the left, you can see that we may have a person who may have a chronological age of 40, but if I was to take a sample of their cells and measure them, their biological age might be more like age 50. And this would be bad, because what it would be showing is that actually they're aging faster than they typically should be. Now, on the other side, you could have someone who has a lower biological age than the chronological age, which would suggest that they're actually aging slower. So the difference between your chronological age on one hand and your biological age on the other is now considered by scientists as a very good measure of really how well you are actually aging. And whilst a lot of people, kind of say, oh my goodness, do I really want to know what my biological age is? Do I want to test it? For scientists, this actually proved two really important points to us. The first thing it proved that was aging is not fixed, because for a long time it was believed that aging was this process that once the march of time had started, there was absolutely nothing that you could do to slow it, to stop it, to even reverse it. But if this was true, it would mean that our biological age and our chronological age would always be identical, but they are not. The second thing that it really proved is that we can actually measure the aging process. So a big question within the aging field was always, okay, if we are going to try and slow cellular aging and reverse biological age, then how on earth are we actually going to measure that we've been able to do this? So this actually proved that it was possible to, first of all, alter the aging process, and it was also possible to measure it. So a key question is, okay, so if there is a discrepancy between biological and chronological age, and that shows us that something is going on at the cellular level to either speed up aging or to slow down aging, then what is it that's actually causing cellular aging? And what we know is that there are actually 12 key processes that seem to be going on within our cells to cause the aging process. And these are very well known now within the longevity space as the hallmarks of aging. And you can see them here. There's lots of different hallmarks, and some of them you may have heard of, things like genomic instability, which is DNA damage, senescence, which is something that's been spoken about a lot more, telomere shortening. Now, I don't have time to go into all of these today. That's a completely separate webinar. But the one thing that I am going to focus on, the one hallmark, is mitochondrial dysfunction, because this is very, very relevant when it comes to what Dr. Erik will be talking about in terms of the lasers. So first of all, what are our mitochondria? So our mitochondria are, if you've ever seen them, if we were to look at our cells in a microscope, you'd see all of these tiny little funny shaped, wiggly things, and there are mitochondria, and there are hundreds of thousands, if not, millions of these things in each cell, and they're often called the energy powerhouses of the cell. They're like the cellular batteries, and what they do is they literally take the glucose out of the food that we eat, and they convert it into the energy that all of our cells need to function. And they do this through the process of aerobic respiration. So they take the glucose, they take some oxygen, and they do a reaction, which is the Krebs cycle, to produce ATP. And ATP is the energy currency of our cells. So they're very important in energy production. Now, what is mitochondrial dysfunction? What actually goes wrong with age? Well, there's a couple of things that go wrong. The first thing to note is that in healthy young cells, we have lots of mitochondria. There's an abundance of these energy generating powerhouses, and they're all really healthy. They're really efficient. You can kind of liken them to having a lot of brand new power stations that are, super efficient, not producing any waste and pumping out a load of energy. However, as our cells age and we start to get mitochondrial dysfunction, two things happen. First of all, there are less mitochondria in our cells. And secondly, there's a lot of damaged and dysfunctional mitochondria in there that simply aren't working as well as they used to. So when I say they're not working as well as they used to, basically what I mean is that they are just not as efficient anymore. So again, going back to that sort of power station analogy, these are the, the old power stations that have been around for years that really should be decommissioned because they're not fuel efficient and they're leaking out a lot of toxic waste, because this is exactly what is happening to our mitochondria. First of all, they are not producing the same amount of energy from the same amount of food that we've always eaten. Our metabolism is going down. And the other thing is that they are spewing out a load of what we call reactive oxygen species, which are these toxic, really reactive molecules that then go on to damage lots of other parts of our cells and in turn produce inflammation, which also happens to be another hallmark of aging. So inflammation is also a leading cause of aging. So in terms of mitochondrial dysfunction, that's what's going on at the cellular level. But what's actually, what would we feel when our mitochondria start to dysfunction? Well, the first thing is fatigue. Our mitochondria are producing all the energy that we need to function. So not only is this fatigue in terms of physical energy and endurance, but it's also fatigue in terms of cognitive function. So we start to experience neurological conditions, brain fog, because our brain cells and neurons rely on a lot of energy to function. The other thing that I've just mentioned is chronic inflammation. Low-grade chronic inflammation across our body is a huge part of the aging process, and faulty mitochondria are really contributing to this process. The other thing that, not surprisingly, we see is metabolic dysfunction. So people that have mitochondrial issues can often have things like insulin resistance, fatty liver disease, real issues with metabolism and all of the metabolic processes that are going on in our bodies. And finally, when it comes to skin, what we see is that in skin cells that have reduced mitochondrial levels, first of all, we are not getting the same level of skin turnover that we used to get. And secondly, the capacity of our skin cells to be able to regenerate has also decreased. So that was a bit of a whirlwind tour of cellular aging and the mitochondria. And I'm now going to pass you over to Dr. Erik, who is going to talk about how laser therapy can actually improve some of the issues that I have just spoke about.
Thanks, Nichola. As we get into talking about the unique combination of low-level laser and looking at nutrition, I think this is something that we consistently see time and time again with the practitioners that we're talking to in the space, is that for a long time, we thought people just wanted to look good. And I think a lot of people still do want to look good, but it's not just looking good, it's also feeling good. And as we start aging, things get achy, we have pain, maybe things don't work as well, maybe we do get a little bit of that brain fog or fatigue, and everybody wants to feel good. And while I think the paradigm is shifting, what's amazing about this is that what we're really finding is that treating and optimizing and improving functionality on a cellular level is really foundational for this process to occur. And what Dr. Conlon just talked about is that mitochondria is genuinely linked to aging, right? So you see not only in the mitochondrial functionality, but you see it in the inflammatory responses that occur. You see it in DNA damage. I mean, there's so many characteristics and components that come to this. So we have to ask the question, like, what is non-thermal low-level laser, but what does it actually do? How is this related to aging? And this is where things get really interesting. So we're going to take you back to some of your early days in physics and just talk really quickly about what photochemistry and light therapy actually consists of. If you take a look at the first law of photochemistry, light must be absorbed by a compound or a multitude of compounds in order for a chemical reaction to take place. For those of you who are familiar with how vitamin D synthesis works, right? You go out into the sun, probably not in London, but hopefully somewhere warm, and you have these sun rays, this photochemical response that occurs that synthesizes vitamin D. There's another chemical reaction that occurs within the kidneys as well, in the liver, and then all of a sudden you can absorb it and utilize it. That's a photochemical reaction that actually occurs that we need inherently preserve and have. The second law is that for each photon of light absorbed by a chemical system, only one molecule can be activated. Now, this is really important. This was part of Einstein's early theories. And what's powerful about that is that we're utilizing this every single day. What's beautiful about getting into understanding how light therapy affects us on a cellular level is that there's so many components to this. Now, when we're talking about lasers in general, there's a massive acronym for the actual laser word, but we're looking at wavelengths, and we're really looking at colors of the spectrum, colors of the rainbow, the Roy G. Biv, the red, orange, yellow, blue, green, indigo, violet. Each color has a different wavelength that's associated with it. And what we know is that visible light has far more energy than infrared light. And I want you to just keep that in your memory box, because this is a really important caveat for the differences between visible light and infrared light. Erchonia actually uses LEDs, light emitting diodes, for their placebo and their double-blind multivariate level 1 placebo-controlled studies, because not all light is created equally. And what's interesting about this too is that the higher you go in these wavelengths, the more heat you deliver to those surrounding tissues and water molecules. Well, let's think about this for a second. Nichola was just describing reactive oxygen species and inflammation. What happens when you have a cut or you have an inflammatory response? Things get warm, they heat up, right? We have this inflammatory cascade that occurs, but we have the production of reactive oxygen species. Now, these things can age us really early, and they can age us quickly if they're always consistently around. So this is really important for us to understand, is that when we're talking about the visible light spectrum, it's one of many different components of different aspects of photochemistry and different types of wavelengths that we encounter. So, we have different things going from really, really short wavelengths like AM radio and television, all the way up to like X-rays and gamma rays. And for most of these things, we actually can't perceive them. We know some of them aren't as healthy for us, but what we're talking about with lasers, we're talking about the therapeutic dose response. This amazing kind of opportunity for us to create technologies that upregulate cellular functionality. And lo and behold, guess where it all begins? It begins in the mitochondria. It's an amazing technology that can upregulate mitochondrial functions. And this is what's really amazing about it, is that laser therapy can throw billions and billions of photons of energy inside a cell, and it can optimize cellular functionality. Specifically, we used to think it was based off of the cytochrome C oxidase enzyme, which is in the fourth complex of the electron transport chain. If you don't know what that is, don't worry about it. I'm going to run through it a little bit here, but what I want you to understand is that this was the rate-limiting enzyme for producing ATP. Well, Dr. Conlon just mentioned and talked about the importance of ATP and what happens to mitochondria that either are no longer functioning as well, or you don't have the quantity of mitochondria to function as well as they used to. And their whole goal and functionality is to produce ATP. Now, this is a really important mechanism for us, because we used to think that mitochondria were only there for producing energy. I know I was taught that when I was in school, but now we know that mitochondria can actually control inflammatory responses. They're really important for immune regulation. Having too much or too little immune regulation is actually a big problem for a lot of people. And so your mitochondria, the more we learn about them, the more we're realizing that this is truly the keystone for looking at aging and longevity and optimizing functionality. Now, here's a little schematic about what these photochemical mechanisms actually look like. So you have these billions of photons going through the cell membrane, and it's affecting that cytochrome C oxidase enzyme. There's actually other enzymes that are being activated based off of different wavelengths that we'll talk about. But what happens is that it has an inherent effect on all these different complexes inside the mitochondria. Every single one of these complexes in some way, shape, or form is heavily, heavily influential in the production of ATP. Now, inherently with them, a lot of them are actually producing hydrogen atoms. And those hydrogen ions actually roll through and they go to this ATP synthase enzyme, which utilizes hydrogen to go from ADP, adenosine diphosphate, to produce ATP, adenosine triphosphate. Now remember that ATP is the energy powerhouse, and that's what every single cell uses to maintain functionality. What we know about low-level laser therapy is that it's actually influential in cellular proliferation and cellular migration. It's got influence on cellular adhesions, that's scarring, that's abrasions, and it also has an influence in apoptosis, aka controlled cell death. Now, why would we want to lose cells? Well, as Dr. Conlon was alluding to, sometimes we have cells that should have been let go a long time ago, but they stick around. These are called senescent cells or zombie cells, as they're talked about in the literature. these cells actually limit our other cells' functionality and capacity to operate. And this is really important for us because what we're finding in the aging space is that different types of senolytics, things like quercetin, can be really effective in improving our functionality and reversing signs of aging. Now, what's amazing about either new Cheetos products and also Erchonia's products is that we know that all of these mechanisms can affect multiple tissues because every cell in your body is affected by ATP and mitochondrial functionality. We know laser it can actually have positive effects on blood, epithelium, joints, muscles, bone tissue, even neurons. Now, what we thought originally was that specific wavelengths would have specific influences, but we weren't fully sure as far as the physiology or what was actually going on. Early stage research was done on the red wavelength, right? So this is anywhere between 620 and 750 nanometers. We talked about the cytochrome C oxidase enzyme that's being affected by this fourth complex, that rate limiting enzyme for producing ATP. Well, what we're realizing is that there's actually other mechanisms at play. But I want to point something out really interesting with regards to this. So if you take a look at the photo on the right side of your screen, what you'll see is that as these photons come in and affect the cytochrome C oxidase complex, you'll see that oxygen binds to this iron cytochrome C oxidase centered enzyme, but what it gives off is nitric oxide. Well, for the providers in the room, what does nitric oxide do? It's a local vasodilator. So what you're actually going to see is you're going to see increased blood flow, which brings increased nutrients. It's going to take away garbage and residual trash that is probably at the site of injury. What's amazing about that is you have this inherent kind of filtration system that's occurring with that. And what we've realized with recent studies, this was a recent study that came out over the last 2 months, is the fact that different wavelengths actually affect different complexes in the electron transport chain. This schematic is really interesting. We know that violet blue light actually affects the first and second complexes in the electron transport chain. We know that green light affects the third complex. I mean, you know that red light affects the fourth complex, that cytochrome C oxidase enzyme we were just talking about. Now, what's interesting about some of these is that we actually know that complexes 1 and 3 are quite susceptible to loss of activity due to aging, chronic conditions, and pharmacological drugs. That's important for us to understand how therapeutic not only sunshine can be, but different wavelengths of laser. And now what's really interesting about that is there are a lot of lasers on the market today that talk about being high power, having greater photon usage, and being able to say that we can have a shorter treatment time with the type of lasers that we're using. But by adding more power, what happens is that we're actually increasing the heat and we're increasing the loss of different types of photobiochemical reactions that are occurring in these tissues. And increasing the power doesn't actually increase the depth of penetration. And what we're finding too is that as we have more heat, we have more reactive oxygen species, we have more inflammatory responses, we have actually more cellular damage. And there's multiple studies showing that low-level laser delivered over a longer period of time at a lower power is actually more effective than the same amount delivered in the same dose. Now, these articles are interesting because they kind of refute common knowledge or common beliefs or commonly thought beliefs about high-powered lasers or high-powered mechanisms. And I promise you, Dr. Conlon can talk to you far more about that than I can, about trends that occur in the industry, because this thermal heat is usually removed as unused and wasted energy. More importantly, too, what we're actually doing is we're actually promoting the denaturation of proteins, the denaturation of DNA as well. We know that the light spectrum is too energetic for vibrations of the water molecule, and so even with things like infrared light or UV light, we know that those mechanisms are actually not going to have the cellular outcomes that we're actually hoping for. And this is really important for us because what we know is that different wavelengths have different functionalities. And so wavelengths at the 635 nanometer mechanism have mitochondrial activity. They have proliferative cellular activity in a beneficial way. We have the production of IL-10, which is an anti-inflammatory precursor in interleukin. We know that the 405 nanometer, the violet wavelength, has antiviral, antifungal, and antibacterial functionalities. And we know that the 532 nanometer wavelength, there's a reduction of TGB beta, which is a really important inflammatory marker. Now, we can go all day talking about light therapy and why it's important, but I think this is really important for us to understand is that laser is different than light emitting diodes. And the reason why is that laser is collimated, it's coherent, and has a deep depth of penetration. And light emitting diodes, like I said, we use for placebo effects with our studies. Now, Erchonia is not just about pain, but we're looking into diabetic neuropathy, we're looking into Alzheimer's, we're looking into autism, and we just got FDA clearance for post-surgical pain because of the therapeutic benefits that occur with low-level laser therapy on a cellular level. And this is an important mechanism to understand going into Dr. Conlon's next state, is that the mitochondria are not only foundational, but there are a lot of things that we thought we knew about mitochondria that are no longer true today. And not all nutrition, not all products on the market today are created equal. And so with that being said, I think this is something that's really important for everybody to think about, is that everyone's thinking about NAD+ and they've heard about it, but let's hear it from Dr. Conlon to see what's actually going on with NAD+ and the cellular mechanism that's going on in the mitochondria. So Nichola, I'm gonna hand it over back to you.
Thank you so much. That's, even for myself listening to that, it's so interesting to hear all the science behind the product. So yeah, NAD, if it's something that has become somewhat of a buzzword, you know, within the longevity space, within the industry, and it stands for nicotinamide adenine dinucleotide, and that is why we abbreviate it to NAD or NAD+. So what actually is it? Well, it's involved in hundreds of different cellular processes or cellular reactions, but it's most famous for two things. The first thing is for cellular energy production, and the second is for cellular maintenance and repair. So as a general rule of thumb, if you have high levels of this cellular NAD molecule, you will have lots of energy production and you will have lots of repair. On the flip side, if you have low levels of cellular NAD, then you will have low levels of energy and low cellular repair. So what has NAD got to do with energy production? Well, if we just go back to this mitochondria again, remember I mentioned that the way that the mitochondria actually produce energy is via the Krebs cycle. So the Krebs cycle is involved a lot with the electron transport chain and all the functions that Dr. Reis is talking about. But the main reason that NAD is important is that it's absolutely critical for this cycle. So when the molecules are basically moving through the Krebs cycle and they're losing and gaining hydrogens and electrons, it is the NAD molecule that is assisting this by accepting and donating the hydrogen and the electrons. So NAD is absolutely critical for the Krebs cycle that is producing the energy. And if you didn't have any NAD, you would literally be dead in 30 seconds because your mitochondria would just not function. So what is the link between NAD and repair? Because I also mentioned that NAD is really important for repair. Well, in this instance, NAD performs a slightly different role. And what it does is it acts as a fuel for a group of proteins called the sirtuins. And these sirtuins have become quite famous within the longevity space because they're basically a family of longevity proteins that when they are activated, they switch on many pathways that are associated with cellular health. And the link between sirtuins and NAD is that NAD acts as the fuel for the sirtuins. So without NAD, just like the mitochondria, the sirtuins will not function and we will not have any beneficial repair happening in our cells. So just going back to the mitochondria again, what we know is that if you have NAD in your cells, you are not only getting efficient energy production by the mitochondria, it's absolutely critical for that, but it also has a whole host of other benefits to mitochondrial function. First of all, it's actually helping with the recycling of damaged mitochondria. So this is a process called mitophagy. So autophagy is the recycling of damaged cellular parts, but mitophagy is actually the recycling of damaged mitochondria. And it's important that these damaged mitochondria are removed from the cell, because if they're not, they will be given off reactive oxygen and you'll be getting damage in the cell. So NAD actually switches on the sirtuins that actually switch on some of these repair and maintenance processes and recycling processes for the mitochondria. mitochondria. The other thing that NAD is really important for is for the production of new mitochondria. So this is called mitochondrial biogenesis, and we see that as NAD levels increase, you actually get an increased synthesis of new mitochondria. So this is why in younger cells we see that they have a lot of mitochondria producing energy. And the final thing that NAD does to actually improve the mitochondrial function is that it makes the mitochondria more efficient. If you have NAD that is available to that Krebs cycle, that process of energy production becomes more efficient, which means that you get less reactive oxygen, so less toxic byproducts from the reaction, which in turn means that you get less cellular inflammation. Now, the reason that NAD has become so talked about within the aging space is that it's been found that NAD actually declines with age. So when you're young, you have really high levels of NAD, but as you get older, unfortunately, your NAD levels decrease. And it's estimated that this decline is really quite drastic, that it's around 50% every 20 years, and this is from birth. So basically, you've got the levels that you're born with. By the time you're 20, they've halved. By the time you're 40, that is halved again, and so on and so on. And that is bad, because if NAD declines, you are not only reducing energy production, but you're reducing repair, you get cellular dysfunction, and this manifests as a lot of the signs and symptoms of aging. So scientists have kind of said, okay, if we've got this NAD molecule in our cells and it's declining with age, then why don't we just not let it decline with age? Why don't we boost NAD levels, or indeed keep them elevated so they don't decline as we get older? So there have now been a lot of studies, hundreds of studies now, showing not only in cells, but in mammals and also in humans, that if you can restore NAD at the cellular level, it improves all around cellular health, and it contributes to something called health span, which is increasing the number of years that we live in good health. So the proportion of our lifespan that we are healthy, which is really important. As Dr. Reis said at the start, we want to be living in good health and feeling good. So the types of things that are associated with increase in NAD levels are not only improved energy levels because you have improved mitochondrial function, but we see improved muscle function. That's in terms of stamina, endurance, and recovery. We see increased cognitive function in the brain in neurological conditions. We see the repair of damaged DNA at the cellular level, showing that those repair processes have been turned up, and also, enhanced levels of immune function. Again, we know that the mitochondria and NAD are closely linked to immune function. So there's a whole host of benefits that are body-wide that we see when we are increasing NAD. So a key question was, okay, so how on earth do we increase NAD levels and reap all these benefits? And some time ago, when this was all discovered, the first sort of logical thing to do was, okay, well, if NAD's gone down, then why don't we just put more NAD back in the body? So you started to see supplements that contained pure NAD popping up on the market, and unfortunately they do not work, and this is because NAD is a very unstable molecule. We also saw things like NAD drips, NAD injections, and all of these things starting to come to light. But the issue we have with this is, as I've just mentioned, NAD is a very unstable molecule. It's meant to be inside of the cells. It does not survive well outside the body, which means that if you put it in a pill, it will be degraded. But even if you bypass pills and bypass the gut and you put it in IV drips or you inject it, this is also a problem, because although it overcomes the bioavailability issue, the issue that it doesn't overcome is the fact that NAD is a large molecule. And although you can get it into the blood, it doesn't actually do much at all in the blood. It needs to be inside of the cells, because that is where the mitochondria are, and that is where all the important cellular pathways, the DNA, things like that, which NAD interacts with, are found. And it cannot cross the membrane of many cells. It is too large and it needs special channels to actually get through, and many cells simply don't have this. So the next sort of suite of NAD boosting products that came out were what we call precursors. And if you have heard of NAD at all, you have probably heard of precursors such as NR or in particular NMN. And what precursors are they are the raw materials that your body basically uses to make NAD. And the idea behind these is that if the NAD molecule is too large, then basically you just give the body some of the smaller building blocks, and hopefully the body will take these building blocks, put them into the cell, and actually convert it into the NAD molecule. But there is now a lot of evidence coming out to show that all the science shows that this approach might actually cause further problems such as methylation problems, which we certainly don't want, as methylation groups, methyl groups are very important for a lot of other processes in the body, and also that it may inadvertently be driving inflammation, which again we do not want because inflammation is a leading cause of aging. So if these are the issues that are being caused, why are we getting these issues? And the main reason is that by using pure NAD or using these NAD precursors, which seem to be everywhere right now, you are not actually addressing the root causes of NAD decline. So what we now know is that the main reason, or the main two reasons why NAD is actually declining in our cells as we get older is firstly, because older cells have been around much longer, they've got more damage, they've got more inflammation, and they need more NAD to drive the repair of all of this damage. So basically they have a higher NAD demand. Now, at the same time, what we see happening in the cells is that our ability to make NAD from these precursors and to recycle NAD as it is used up actually declines with age. So key enzymes that do this manufacturing, that take the precursor and turn it into NAD, decline with age. So if you put both of these things together, you are going to get a deficit. You've got increased demand and you've got a decrease in production. So if we are thinking about precursors, sorry, just go back once more, one slide, Eric. Next one. There we go. This is my factory analogy. So if we are thinking about precursors, why are they not the best approach to boosting NAD? Well, if you think of the cell as an NAD producing factory, if you went to this factory because you saw that NAD production had gone down, and you went in and you saw the reason production had gone down was because all of the machines were broken and the pipes were leaking, you would definitely not be saying, let's just order some more raw material and put it into the factory, ignore the fact that all the machines are broken, and hopefully we'll get better production at the end. You would be going in there saying, don't order any more raw material until we get this factory fixed. So right now, the latest scientific evidence shows that the best way to boost NAD is actually fix the reason why it is declining in our cells. So this is exactly what we have really focused on, our scientific team at Nichola, was actually to develop a product that encompasses and actually fixes all of the root causes of NAD decline. So you can see here in this image, it's got all the different enzymes and the pathways that are all involved in actually producing and making and recycling NAD, and some of the pathways that are actually degrading and wasting our NAD as we get older. And all the ingredients in this supplement are essentially designed to fix all of these issues. So to switch on natural NAD production and recycling by restoring the factory, by inhibiting inflammation that's wasting NAD, and making sure that we are addressing any methylation issues in there, which could also be causing issues like NMN and NR do. Now, because of my background in drug development and as a scientist, I'm always very keen about having good clinical evidence, and that's why I was so excited to do, this webinar today with Erchonia and Emerald Laser, because they are extremely passionate about the scientific evidence and the clinical testing as well. And for our product, we also did a full clinical trial. It was a randomized, double-blind, placebo-controlled crossover design, which is basically a gold standard as far as clinical testing goes. And there was a number of different things we wanted to measure in this trial. The first thing that we wanted to actually look at were NAD levels. So just the next slide, great. So what we saw when we measured NAD levels was that, we essentially wanted to prove that this product was actually boosting levels of this critical cellular molecule. And we saw that after 28 days compared to placebo, we had a significant increase in NAD. The next thing that we wanted to look at was, were we actually fixing the root causes of NAD decline? We know that the main issue of why NAD is declining in the cell is because the main enzyme that is recycling and producing NAD from these precursors, aka the factory, has declined. So we measured levels of this enzyme called NAMPT, and again we saw that after 28 days we got an increased level of this key enzyme in these volunteers. So this shows that we are actually fixing the root cause of NAD decline, and currently it's the only product on the market with human clinical evidence to show we're actually fixing the problems in the cell. The other thing that was really important to measure was inflammation. Again, inflammation, I can't stress it enough, it's a huge part of the aging process. And we saw a significant reduction in several different inflammatory cytokines, which again tells us that we are addressing some of these cellular hallmarks of aging, and also improving mitochondrial function, which we know is reducing inflammation levels. And finally, I just want to mention biological age. Now my graph is gone. So usually there is a graph there. So this is probably a formatting error because I don't usually use a Mac. So it's probably gone between PowerPoint and a Mac that it's disappeared and left everyone in suspense. But basically what we did was we measured biological age. So remember at the start, I was talking about how biological age is a good way to measure if you are actually reversing aging at the cellular level. And what our results actually showed was that in 28 days of actually using the supplement in our trial, we were able to reverse a person's biological age by 1.26 years in 28 days. So what this shows is that we are really impacting the hallmarks of aging to have an impact on cellular health, which is truly reversing aging at the cellular level.
Someone must have stolen your graph at some point, Nichola.
I think you must have done this to me. You're like, that is the golden nugget. I'm going to take it off.
Here's what I can say. I am currently taking Nuchido, and what sold me on Dr. Conlon's product is just the fact that not only is she brilliant and has the background to really justify this, but much like Erchonia, I love clinical research. I love clinical trials, especially when they're on humans. I think that is such an important caveat, is when you start looking into the data in the literature. I mean, they have mice models, they have rat models, they're doing things with monkeys, they're doing theoretical studies, and you're looking at different enzymatic pathways. But I think something that's really important to discuss is that human clinical trials really matter. It's one of the reasons why Erchonia does human clinical trials. Double-blind, multivariate, placebo-controlled level 1 studies that are very, very difficult, if not nearly impossible to even fake, right? And Nichola, I think that's one of the things that I love about what you built as well too, is the fact that not only are you a researcher, but you're practical and you're backing up what you're saying, because it's not cheap to run a study, right? And so I think it's really important for people to understand the value that really comes from having that evidence. And so Dr. Conlon and I just wanted to have a moment to really just talk about, why this beautiful kind of unique connection with, low-level laser therapy and putting together like high-quality nutrients with Nuchido. And so, Vanessa, maybe we'll break to you just to see if there are any questions from any of the attendees right now before Nichola and I kind of give a last-second overview of what we have going on. So I'll throw it over to you.
Perfect. Thank you guys so much. That I found that so interesting. I also have been taking Nuchido now for about, I think this is my 3rd month, because I'm due my renewal, which is great, by the way. It automatically does it, so you don't even need to think about anything. So it makes life a lot easier. I think one of the big questions is, in terms of a clinic, how would they implement the best possible protocol? Let's say you have a clinic that has the Emerald and they also have Nuchido. How would they combine the two together to get the best possible patient outcome?
Yeah, so I think what's really important to recognize is that when it comes to aging, there's never one thing that is going to be the magic answer, because if we just think about those hallmarks of aging, all of those different 12 cellular processes that are all going on, they're all impacting each other, they're all affecting cellular function. So really for aging, you really want to be encompassing, incorporating a strategy that encompasses multiple different angles that you're attacking the problem from. So the real synergy, I think, between using an NAD supplement like Nuchido Time Plus alongside the laser is almost a way of priming the cells to ensure good cellular health, so that when you are doing the treatments, you're almost starting off from a better level. So for example, if you can be, what we'd always recommend is that we know from our clinical study after 28 days that we're already seeing increased NAD levels. We're seeing cells that are acting younger biologically. We're seeing reduced inflammation. So basically, in making sure that your patients are priming the cells ready and then going with something like the laser on top of that means that your cells are ready to react. They are ready when the laser is working to actually deal with, I know it puts the pore holes and the lipids leaking out, and you've got to have all the cellular recycling processes active and switched on to be able to deal with that. So it's making sure that you are putting your patient in the best possible place to be able to respond well to that treatment.
Yeah, and I would agree with that wholeheartedly. I think as an addition to that as well too, as providers, there's so many components that can be thrown into this. And what's amazing about the laser is that it's so versatile, right? So, if somebody is taking a product like Nuchido, they're getting high quality nutrients, that their epigenetic profile, the expression of their DNA is literally changing based off the fact that you're having alterations in inflammation, immune modulation, all of these beneficial things for your patients. What's beautiful about the laser, though, is that we can use it over specific areas of the brain and body to get higher outcomes. And so one of the ways that I would suggest for providers out there who either have the Emerald or you have an EVRL, or maybe you have one of the stands like an FX635 or 405 is you can use that to facilitate different processes physiologically in the body. And so for an example, right, Erchonia, we're always talking about the vagus nerve and vagal nerve stim, right? Here's a newsflash, right? You need an intact vagus nerve to actually absorb Nuchido's products, because it controls everything from here all the way down to your large intestine. And so what's important for that is a lot of people's vagus nerve or their vagal tone becomes negatively affected during inflammation, poor gut functionality, poor food nutrition. It just happens in chronic disease states. Stress is a great example of the yin to the yang. If you're stressed, your vagus nerve doesn't function as well. And so what's important is getting a baseline with Nuchido products, but then on top of that too, utilizing the low-level laser to upregulate vagal tone by simply placing it over the side of the neck where the vagus nerve wraps around your carotid artery, or throwing it over the gut for 5-10 minutes to make sure you're actually getting proper absorption. I think the difficult component with what we're talking about is the fact that some people may not be absorbing food or nutrition as well as they could be. Well, the first thing to do is make sure you get those nutrients into the body. On top of that too, if you can upregulate any sort of processes neurologically to help them optimize the absorption rate of those products, you should do that. And that's where using great supplements like Nuchido, plus with amazing technology like low-level laser, can come in handy, because they're facilitating, they're augmenting each other. There's a term used in we'll say neurobiology, specifically we're talking about like the entourage effect. Whereas when you have one molecule, it can get so far. When you have another mechanism, it can only get so far. But together, they have twice or 3 times the capacity to be able to facilitate healing. And if for a clinician out there, not only do I think you using the laser in that fashion, but getting your patients to use the laser repetitively and repeatedly. The Emerald results for a lot of the docs out there aren't just actually getting fat loss. A lot of these patients are coming in saying, I feel better, I'm sleeping better, my mood is better. And while that's an off-label outcome that we would say, the best part about that is that it's functioning on a cellular level, much like what Nuchido is doing as well. So there's multiple ways to use that, but in my opinion, I think that that's a great kind of entourage component to take away.
Yeah, it's really a synergistic effect, isn't it? And, you know, just looking, you know, honing in again specifically on the mitochondria, if we remember your diagrams of the electron transport chain and all those different complexes, you've got NAD, which is doing one part of the work that's completely separate to these complexes, which the laser is then switching back on. So you put them both together, you are getting double the impact in terms of the functionality of the treatment, the outcomes of the treatment, and how the patients are actually feeling from that.
And here's the caveat to all of that, as you actually know it's going to have a high probability of working because there's human clinical trials showing the efficacy for that. I think that's something that just needs to be said, is that it's no longer theoretical. It's not just a mechanism we think we know. Like, these are actually peer-reviewed journal article-backed research studies that justify the therapies and the outcomes. So that's what really sells me on all of this. And for the providers, your results will speak for themselves. I promise you that.
Absolutely. A question that I have is, what country, because we have quite a few international customers on this webinar, Nichola. So what countries is Nuchido currently available to purchase in?
We do ship worldwide, but in terms of like where, you know, cheap and fast shipping is available to would be the US and the UK and the EU. We do ship worldwide, but we, you know, in terms of being approved in particular countries, it would depend on customs and regulations for shipping.
Okay. One of our clients has an Emerald, an FX, and an EVRL, and they're based over in Switzerland. And I think she's thinking of introducing Nuchido into her patients. Would this be something that she'd be able to introduce in Switzerland, or I suppose that's a conversation she can have with you?
Yeah, I guess if anyone wanted to chat further and had specific questions on shipping and countries and things, they can email us. I'm sure you'd be able to provide a contact for us to do that.
Yes, we will. So everybody will receive the recording, and you'll also receive contact information as well. So even after this webinar, if you have any more questions, please just email them across and we'll get back to you. It'll also be uploaded to YouTube as well, so you can watch it back if there's anything that you want to recap on as well. One final question. With Nuchido, can it be combined with taking other types of supplementation as well?
So it can, but what we say is just double check that anything else that you are taking or your patients are taking doesn't contain the same or similar ingredients, to avoid, you know, doubling up and taking over the recommended daily limits. So that is the main thing really to look out for, because a lot of the levels of the active ingredients in our product are high, because we're really, again, a big passion of mine is bioavailability and making sure that there's good levels and of the material in there to actually get into the cells to perform its function. So we'd just say, just double check.
Okay, perfect. Well, thank you so much to both of you. I absolutely loved that webinar, and I really hope that everyone attending it kind of sort of gave you an idea about, now is not the time to just be treating externally. Times have changed, technology is advanced, science is advanced. So it really is about the whole approach of treating like inside out, as opposed to what we're used to is treating from the outside in. So that's a big change that I think we all we can take home from this. So thank you both, and thank you everyone for attending this evening. Any questions, please send them across. You'll receive an email tomorrow with the recording, and yeah, we hope to see you soon. Great, thank you.
Thanks everyone.
Thanks everyone.
Bye. Bye.